first biological neural networks consisted of 300 neurons. The human brain has more than 100 billion neurons and trillions of nerves. And today, we are developing the silicon neural networks, and we already have few thousands interconnected neurons. Somebody like to call it artificial intelligence. We call it tools. Tools, originally intended to enhance human abilities to solve problems. And in all its diversity, at the end, they enhance either energy or information process. Usually, when we face new problems, we solve them with new tools. Artificial neural networks are such promising new platform capable to solve these problems. The neuron is the fundamental building block of all neural networks. Biological neural networks are a system of interconnected neurons which communicate using electrical signals and chemical cues. There are many theoretical works and practical implementations in this area, including perceptron, connectionism, Lisp machine, support vector machine, deep learning and many others. But there are few things missed in most mathematical models of neuron. Connection mechanism, which supports axons grow. Replication, allowing to make more neurons on demand. And actions, which will happen in response of input signals. To fill this gap in artificial neural networks, we developed new model, the virtual neuron. Our model utilizes chemical and electrical properties altogether. It implements connections, replications and motor functions of its biological prototype. Virtual neural network runs similar to virtual machine in varieties of computing environments. To learn and experiment with virtual neural networks, you can download Exploratorium to your computer following the link. Exploratorium is a small program written in Java. It demonstrates all major basic function of virtual neuron, such as cloning, connection, signal propagation and others. Cell reproduction is the process by which a parent cell divides into two or more daughter cells. Virtual neuron can replicate itself into two or more neurons triggered by local, remote or internal signal to clone. It can use DNA analog to create neurons with preloaded parameters. To reproduce virtual neuron locally, there is a method clone in the corresponding object. In Exploratorium, this call can be initiated by clicking on C button at the right bottom corner. The same method can be initiated remotely. In this example, HTTP request, initiated from the browser using simple JavaScript function, will result replicating specific neuron n times. Virtual neurons can use so-called DNA code to initiate cloning automatically. This process controlled by the timing sequence attached to the particular neuron. At the proper moment, neuron reproduce itself and load into the clone the DNA sequence, which will lead to another automatic reproduction. When two neurons decided to establish connection, both will simultaneously initiates different actions. Postsynaptic neuron develops netrons, special chemical, which guides axons. Presynaptic neuron activates axon to find the gradient to the pairing dendrite. As a result, two neurons find each other and establish functional link. Virtual neurons can imitate this process. Let's clone few neurons and create few connections. In our case, postsynaptic neuron is the one which hold green netrons. When neuron develop netrons, greens, it will be attractive for certain period of time. After that period, neuron back to the neutral state. If you activate axon in presynaptic neuron, it will connect to every neuron which hold green netrons. When neurons connected, they can fire signals. Signal will be transmitted to connected neurons according the traditional protocols, considering the weight of the connection. In this demonstration, we just created simple loop, which illustrates how we can build dynamic connections in virtual neural network. In electronics, a flip-flop is a fundamental circuit with two states, which can be used to store state of a system or process. We can call such states as a short-term memory. In our model, we can build structures with similar functions. Even more, we can create triggers with more than two states. We call these structures long-term memory. Such triggers are very important component in conversational systems, allowing to keep deep context of dialogue in a form of short memory. As we already know, virtual neurons can be associated in groups. So-called sensory neurons can receive local and remote signals. And neurons we call motor can initiate internal and external actions. Action can be JavaScript function, HTTP or WebSocket request or any remote call supported by environment. In biological neural networks, connections happened in three-dimensional space. In virtual models, even in n-dimensional. But for human, to understand and model complicated system, it must be presented in two-dimensional hierarchical format. We use convenient way to visualize virtual neural net by organizing groups of neurons in layers. In this example, we create a simple neural interpreter which can correspondently translate from one language to another. As the result, JavaScript program reads the text, sends signals to the input layer, which represents Russian dictionary, and through the hidden layer, excites corresponding English words. Now we have bricks. What can we make with them? Before we get down to explain what can we make, let's look at virtual neurons from above. Programming neural networks, in other words, neuroprogramming, is fundamentally similar to a musical composition. The composer creates a piece of music and writes it down as a musical score. The orchestra interprets the scores, and music arises a dynamic state or process in which sounds form melodies, and melodies are harmonized into a symphony. Programming virtual neural networks is a similar art process. Group of experts create model with different structures. Linguistic triggers, flow charts, fuzzy variables. And these structures are dynamic by nature. Virtual neural network is ideal to create personal profiles and personal assistants. It will help in integration traditional AI tools with personal content and context. It will make interaction between providers and consumers much deeper and efficient. We believe that formula for success in building user interface capable to solve these problems is an integration artificial intelligence with three components: conversation, context, and content. Conversation, either chat or voice, is asynchronous by the nature. User may jump from one topic to another and return back. Neural network is perfect to model Petri net and flow charts, and we developed D-elegance editor, which combines both. Every knowledge domain could be defined by specific set of parameters. Context, in our case, is interconnected influence of one parameter to another. For example, in medical diagnostics, every problem comes with specific combinations of mutually dependent factors. There are statistical learning and expert-based definition of these parameters and weights of their influence. Our solution allows to experts relatively easy transfer their knowledge and build decision or recommendation models. Content is a set of answers or any data collected in personal profile by individuum. We use local database where initial recording of personal data happened. Also, inspired by HyperCard, we created 256 Notes Organizer, the authoring tool, which helps to organize smart content. Because we can connect virtual motor neuron with external function, for example, JavaScript, associated with cards, reaction could be dynamic and dependent on context of current conversation. Conversation, context, and content are three deeply integrated components of Nnod solution. And virtual neural network is a glue which connect everything together. Nnod wouldn't be possible without these people who advised, helped, and contributed in research and development during many years.